This lecture marks the beginning of a new chapter, Chapter 6. In Chapter 6, we will have a closer look at classes and objects. Before we do this, and before we talk about the first couple of sections, which are like what are static class members, how to overload methods and constructors, I would like to have a quick review of what we covered so far in CS14. I believe this is going to help you so we can recall what we covered so far, and then we start in this chapter to build on top of that. So let's have a quick look here. So if we have a look here, we have the basics that we covered, right? So we covered how to print to screen, and we said we have print line, and print f. Then we have we also covered how to prompt or read from keyboard, and we said this requires a scanner object to do that. We also learned about primitive data types. So primitive data types, and we said we have 8 of these, 6 of them are numeric, and then 2 which are the Boolean and char, or the character. We also learned that we can do widening conversion. Narrowing conversion is not possible, it's not allowed, syntax error, you need to do casting, and so on. So these are the basics that we learned just to learn how to interact and write a very basic program. So that was the purpose, how to write a basic program. Right? So then what we did next is that we covered classes and objects, and we said that this is the core. This is Java's object-oriented programming, right? And we are trying to learn this, how to define classes, what are objects, and so on. So this is the core here of what we are trying to learn. All right, so classes and objects. Then we covered very discrete topics. We covered random class. We covered decision structures. And we said we have a few of them. We have if else, if, and switch statements. And then the last thing that we covered, we just finished that one in the previous lecture, which are the repetition structures, loops. And we said we have 3 of these. We have while loops, for loops, and do while loops. We said these 2 are pre-test, this is post-test. We also talked about break and continue, keywords, and how to change the behavior. So again, all of these, once again, all of this that we covered, these are basics. It's not very unique to object-oriented programming. You usually need these in any programming language to interact with the programming language, right? Write a very simple program and get things going. To do something more sophisticated by decision structure, branching out, repeating things. So all of these are concepts that are programming concepts. Classes and objects, that's the part that is unique, and it's related to object-oriented programming and any other object-oriented programming as well. But here in Java, this is what we are covering. So that's what we want to focus on. And I'm going to extend on that to review what we covered so far. Now, when you think about classes and objects, we said that classes can be used in one of 3 formats that we had before. The first one was to use it as a container for application. And to do this, we said we have to have a main method in it. So so this is where Java goes and looks for the main and starts everything from there. So that's the main method in container, as a container for application if you use a class. And this is what we are doing. Basically, every demo class that we show is basically a container that has a main method to get things to run something. The start of this class of usage is using it as a blueprint, as a template. And this is the one that we learned and we used, and this is the key here, how to use a class as a blueprint. The third one that we did not discuss in detail, and this is the chapter where we're going to cover that closer look in chapter 6, is to use it for or as a utility class. We will explain what does that mean. The utility class is from its name, it's utility. It's something that you are using, something that is handy. So how to create a class that provides utility for you. So the one that we want to expand on to review is here, how to use it as a blueprint. And we said we are using the UML representation of classes to understand or to design classes. So here we have the name of the class. Here we have the fields, and here we have constructors and methods, And the main concept that we had, if you remember, we said we don't want people from outside the class to interact directly. Oops, that's not what I wanted. Let's delete this. So if you are some entity here outside the class, here, you should not interact with the fields directly. What we want you to do is to interact with the methods, and the methods, they have access to the fields for you. All right, so we don't want this link here. So that's the key, and that's why we set fields in general to be private, and these are usually public, so we can use them from outside. So that's a summary of what we have done before. I want to keep this video short, so maybe we have a couple of minutes. So what I want to do is to go here to BlueJ, and let's write again the rectangle class, which we covered before. Okay, so if you remember here, we said rectangle class, we had our fields. We set them private, integer, length, private, integer, width. All right, so these are the fields. Then we have constructor. All right, the constructors, we said the first one is the no-arg constructor. And we said this tries to mimic this here, mimics the default constructor. All right, and we said in this case what we do is that it's public. It doesn't have any return data type. It's called rectangle to match the name of the class. And it takes no input because it's no arg. And then what it does is that it just initializes numeric fields to be 0. And if we had a boolean, that would be set to false. So that's the no arg constructor. We could make an arg constructor. So something that we can use to build any rectangle by setting both length and width. And we say we will need to give parameters here. So integer to match the integer of the length and the width. Actually, we could do this though, to make it more flexible. And then here we could also provide double. length double width, and then what we do is that we set the fields to it. Upstairs, length is equal to L, and width is equal to that. Then we said we start to work on our methods, and we said we could build our getters. So public, it returns a double. It's get length, and what it does simply is just to return length. Another getter for the width, which returns the width. Then setters to set the values. Setters are not going to take any input, so it's not returning anything, but it takes an input. So double L, double width, and they are setters, so set and set. And here length is equal to L, width is equal to W, and there is no return. Then we said we can also build another one, which is public. It returns a double, and it's called get area, which is going to return length times width. And if you remember, we said that's better, or avoid building here or adding a private double area and define it here that area is equal to length and width. That's not going to work. You will have stale data, so you need to keep it updated all the time. All right, so that's a way to remember stale data was something that we discussed before. All right, so that is something that we can build here. That's a template. So that's what we meant by building a class as a template here, right? Blueprint. This is basically a blueprint. It's not being used, not yet. So what we do is that once we have, let me go back here and delete this. So once we have our class as a template, what you could do next is to go and build instances, right? So you build instances, which are basically, if you remember, like we said, a home design. It's a single home design that you have here, and then from this you go and build multiple homes, right? So you pay a person to design one home for you, right? Just one layout, one blueprint, and then take this, buy material for 3 homes, and go build 3 different homes with the same design. That's exactly what we are doing. All right, so building these instances, a key thing to understand here is that each instance, even though all of them, the 3 of these, share the same structure of the blueprint, each one has its own, what we call instance fields and instance methods. So each one of them has its own length, has its own width, has its own get length, and so on. So it has a copy of everything that was in the fields and methods. All right, so it has its own instance fields, it has its own instance methods. So that's a key concept that would be very, very important for chapter 6 to understand. Now, how do I know that? How do I know that here? Is that I could go and say rectangle R1 is equal to new rectangle 5 and then I go and repeat this process by creating a new reference variable R2, which is pointing to another rectangle 50 and 80. All right. So now these two are new instances. These two are two different instances of the rectangle class. Now, if I go and try to say here system.out.println r1.getLength, and then I go here and say r2.getLength. So here, 1, there we go. The length is 5 here, the length is 50. Now, this instance R1, it has its own instance field, length of 5, instance field width of 10. It has its own instance method getLength, and that's why it gave me 5 here. So when we do something like this, we are calling the instance method getLength that is owned by R1, which is an instance of the class rectangle. All right, so that's a very, very important concept to understand. And here, one more thing to visualize this. If you remember, we said here is a, let's say the stack memory. It's very bad stack memory. So one thing that we said is that if you have, let's say here, 4 bytes, 1, 2, 3, 4, that could be an integer x, which contains a number 6, for example. All right, so that's primitive data type. It's stored this way in the stack memory. All right, now when it comes to R1 that we just created, it's completely different. R1 is here, that is called variable. R1 would be called reference variable, right? And what it contains is not the rectangle. It doesn't contain the length and width 5 and 10 of the rectangle R1. No, it contains an address or an address hash, which is pointing to another memory in the computer, which is called the heap memory. And in that heap memory, it's more flexible to store that complex object, right? Which is instance of rectangle, right? Which has length and it has width, 5 and 10, for example, similar to what we have, 5 and 10. So you see, so that's an instance. You have another R2 here. Again, different address. This is address 1, this is address 2, and it's pointing to another object in the heap memory, which has the 50 and 80 length and width. So it has its own instance field, it has its own instance field. So that's a quick summary of what we covered so far in 1440. And this hopefully is going to help you recall all of this information before we move forward to start talk or have a closer look at classes and objects in the coming video.